Hello, everybody, and thanks for attending another one of our webinars. I'm going to be doing something different this week. If you ever looked at any of the videos that we put out there, that I put out there, I always highlight things that make Onshape unique compared to other CAD systems. Today, I'm not going to do that. So what I wanted to prove is a point that Onshape can hold its own doing CAD the old way with any other system that's out there. So what I'm going to do is do a redesign on this chair. The chair we see here, typical office chair, this area here, this orange bracket is what we want to change. We got some information in our scenario here today from the ID guys. And they said, we would like to change that rear bracket, make it a couple of components, and then use a hydraulic or a pneumatic piston so that you can lean back in your chair and adjust it. So that's kind of where we're going to be going with this today. Let's take a look at this. So what I did, and keep in mind, I'm going to be using just pure CAD today. I'm not going to be sharing my design with anybody. The only difference is that this is all in the cloud. So I could be using this and doing the work I'm doing here on any type of hardware, as long as we get access to the internet. But let's take a look at what I did here. I took that orange bracket and I did a save as, right? Because that's what you do in CAD systems. You do a save as and you make a copy of it. And then now I can start making modifications to this copy. And what I want to do is basically break this guy into two parts and then kind of hinge them together and then put in our hydraulic piston. So in order for me to break up these two parts, I need to cut them in half. And Onshape is a multi-body modeler, so I can take a part and cut it up into pieces and make bunches of parts out of it. So what I'm going to do today is I'm going to say, let's just make a plane that goes through this face here, and we'll offset it. And really, I'm going to use this plane as sort of like the cutting tool for our example here. So I just offset it. We're working in millimeters here. So I have a plane that's offset here. Now I can come in and just say, let's just cut this up. So this is the part we want to cut. This is what we want to cut it with. And say, okay, now right here, here's our feature tree, all the features that we've created. And down here are the bodies. So we had originally one body. Now we have two. We can see that here. And I'll turn off our plane here for a second. And we can see we have this body and we have that body. So I'll say, let's take this one and we'll rename them and we'll just call it like the back part. And then the bottom part, we'll just rename him and just call him like bottom. So now we have our two components. Let's first of all start to work on the bottom component. So I'm just going to hide the top one here. And what I need to do, because I cut them off, is I need to extend off or extend out this geometry. I'm going to come over here and pick on it, these two faces, and I'm going to use this extend tool. What I can do is kind of drag this out, just as I did kind of with the plane, only I'm doing it with geometry here. And we could say, let's extend this out maybe like, let's say 55 millimeters. I'll turn on our back plane just to see that, yeah, it's extended out, far enough so they intersect. So now that I have this here, I'm going to want to kind of round this off. So I'll come in and say, let's just kind of round off the back of this particular component. And we'll pick on some edges here. So now we have this rounded off. And then again, we're going to want it to connect to the other part. So I'm just going to say, let's put in a hole. And we'll use a 10 millimeter hole. And again, there's all kinds of options here for countersinking and all those types of things. But I'm just going to say, let's just put a hole right through the center here, 10 millimeter hole. So now we have our bottom part ready to go. We'll turn on the back part here. And now we want to start making some modifications to this one. So I'll hide the bottom. We see our geometry here. This little kind of area here I want to get rid of. I guess I should give you a little bit of background. Is that this geometry I'm working with is imported geometry. So a lot of the features that we would have in Onshape where we can change dimensions and things like that, I don't have available to me, but we do have a host of tools that allow us to do non-parametric editing, or it might be called direct modeling, but basically working with kind of dumb geometry. So in this particular case, I'm going to come in and say, let's remove some of these faces because we really don't need this stuff hanging out here. We'll pick on these, kind of remove things. And also in the back, these original radiuses that they had in the back of these fillets, we don't really need those as well. So now we've kind of squared this guy off, and we can come in and kind of round him off, very similar in the way that we did the other part. So then just grabbing some of these corners. And we've got that completed. Again, we're going to need to fasten him, so we'll put in a hole. We'll use the same diameter hole and say, let's just put one through the center right here. So now we have our two parts. We'll turn on our bottom part here, and we can see that they're here. Now the holes don't line up, right? Because I centered them on the parts and not really on one another. But that's okay, because these are going to be two different parts, and when we assemble them, we can assemble so the holes do align themselves. So really what we've developed so far is just a big hinge. If you lean back in your chair now, you kind of flip over backwards. There's nothing to keep it from stopping. So that's what we want to do, is put in a pneumatic piston to kind of control the movement and be able to lock it in certain positions and things like that. By the way that this original part was designed, there is no places for us to attach this piston. So this is where I'm going to start going in and creating some geometry, some locations where we can attach this piston to. So let's start with the bottom part here. What I've done to kind of simplify some things is I do have a sketch that I'm going to use to kind of make the little connection point here in the center. First of all, one of the things that I'm going to do is let's get rid of these two fillets that are up here, just to kind of simplify the geometry. So I'm going to grab those, and I can just say delete them. All right, so that just basically kind of squared it straight up. So we just have a pipe coming into our part here. I'm gonna go and take our sketch that I made, and it's really just a square with a hole in it. I'm gonna take that. So we can grab this, and we'll say, let's extrude that out. And we'll say symmetrically. So again, we see a lot of the same kind of tools that we see in other CAD systems, right? Being able to create solid geometry. It's parametric, solid geometry. So here's our part so far. Now, we don't really want to attach the piston on this side or on that side, but kind of in the middle. So I'm going to kind of cut out the middle with the same sketch. So I can say, let's just take that. And again, we're going to extrude it out. And then we have lots of options out here when we're creating geometry. We can add material, we can remove material. This can be a whole new part if I want it to be, because it's a multi-body modeler. In this case, I'm going to say, let's remove some things, remove geometry, and again, kind of symmetric, and give it a value. And now we have a little cutout flange. I can hide our sketch here, and we can kind of start working with this to kind of finish the design a little bit. So I'm just going to come in and say, let's add in maybe a radius, because remember I deleted those radiuses earlier. So I'm going to add in the radius here. And then let's go in and add maybe another radius on the top, a different value. Put it up here. And then let's finish up the design a little bit with a couple of chamfers, maybe on here as well. So now we have our part. We've extended this out, put a hole in it, and now we have a location where we can fit our pneumatic cylinder right in between here, fasten it in, and this guy is pretty much ready to go. So let's take a look at the next component, and it's this guy. And so in his case, we're going to have the piston coming out here. It's going to need to attach somewhere out here. So I need to put a little arm or something out here to connect it on. So I did create a sketch, as we can see right here, and I'm just going to extrude that out and attach it to this guy. So let's kind of hide our bottom guy just so we can focus on here. Same type of thing. I'm just going to say, let's extrude this out. You notice right away, it thinks it's another body. It's creating another body because it's not touching anything. But in this particular case, I'll say, let's extrude them out until you hit this outside face. And then on the other side, we'll do the same thing. So I'm just going to say, extrude you out until you hit this outside face. And when it touches the other geometry, it says by default, well, maybe you want to just add this to the existing geometry. I could make it a whole new part, but really I do want to have this in the same part. So now we have that. I'm going to do the same thing here that I did with the other little flange that I made earlier, where I'm just going to extrude this guy out, same kind of thing. And we'll say, let's, in this case, we're going to have it remove material. And then say, let's just go up to the inside face here. And on the other side, let's go up to that other face on this side. Now, one of the things I could have done in this particular example is I could have just made one of these and then mirrored it over to the other side. But, you know, as long as we get the geometry in there, we're good. So now we have this guy created. Let's turn on the bottom for a second here. So you can see our two parts. I'm looking at it this way. We still, you know, we have connection points now on one part and on the other. So we can put in our piston, but the thing is that these guys are overlapping. So I could do, I'm thinking about this, I could do a couple things. I could put maybe kind of a little dog leg jog here on the inside part or on this part going to the inside so it fits inside, or I can make this part and go either on the inside or the outside. But that would be another machining operation, another stamping operation to cause cost, increase in cost and things like that. So I'm going to use kind of a different approach, is I'm going to use this back part and actually make a part from it. So let's kind of hide our bottom part here for a second. I'll show you what I'm going to do. So we'll take this guy, and what I want to do is convert them to another part, but I'm going to use these inside surfaces. So we know that these overlap, so if I start building my geometry from the inside going towards the center, it should fit. I'm going to use sheet metal to do that. So we have sheet metal capabilities, obviously in Onshape, and I'm going to come in. We can either convert a part to sheet metal, so I could say convert this to a sheet metal part. That's not going to buy me anything, right? Because everything is in the wrong place. We need to move it in. So the other option I'm going to use is thicken, which just means let's add a thickness. Let's create a sheet metal part from the surfaces of another part. So I'm going to pick the inside surface. And you see what it does is adds a sheet metal wall here on the inside, a thickness of 4. And I can put in what I want the bend radiuses to be and the K factor and the corner relief and all of that type of stuff. But in this case, it's kind of straightforward where I'm just kind of building a part by leveraging the inside of this one. So I get the exact same geometry, just a part that's offset, and all the holes are in the same place as well. So now I've created this sheet metal part, and you notice it called it part 3. So I'm going to just change this, and we can just call it like our new back part. So if we hide our original back part, we see that we have this guy. And he's a sheet metal part, right? Like I said. And the reason I can tell that it's a sheet metal part is I can go over here and I can flatten them out. So we see the flattened version here. We see all the different bends. You notice as I touch any bend, it's highlighted in the other 2 graphics areas. Vice versa, if I hit a bend here, it's highlighting it as well in the other areas. But sheet metal is a discussion for another day. Or you can watch one of my other videos where I cover sheet metal. So we have this new part that we've created. So we actually have 3 parts in here. I'm going to turn on the bottom one along with this new sheet metal part that I made, and we can see that they fit together. Again, the holes still don't align, but we're in what's called a part studio where we're just creating parts right now. It's not really an assembly. Even though there are multiple bodies here, they don't really know that they're connected or how they're connected to one another. So that's where I'm going to go and kind of move into the assembly mode. You'll notice that the menus across the top here all have capabilities for creating geometry, extrudes, sweeps, lofts, all those kinds of things, making helixes, making sheet metal. What I'm going to do is now move into an assembly. So I'll say, let's create an assembly and let's start bringing parts in. So I'm going to say, let's insert, and we can expand out. Here's the original top level chair. We want to bring in the bottom part, right? Because that's good. And we want to bring in the sheet metal part. We don't really need the third part or the original back part because we've got a new version of that. So I bring both of those in. So now we have an assembly. Basically, it's taken the two bodies in the positions that they were, and it's placed them here. You notice the menus have changed. So these are the menus that allow me to create the mechanism of how this would work. So if we look at this guy, I can take and drag him around wherever I want. What I really want to do with a mechanism, probably fix one of these guys, and then the other one can move relative to him. So I'll pick the bottom part and say, let's fix that one. So now I can't drag him around. I can still take this guy and move him around, right? Because they're separate parts. And what I can do is say, let's create a revolute joint. In old school ways, I always just call these pin joints, but I'll say just between the center hole here, now we're going to be aligning the holes to the center hole here. So now we've got our pin joint or a revolute joint. And what that means is I can take this guy, and now we've got this type of motion. So this is a good start. Now we know that the holes are aligned. We've got our parts sitting here. The next thing I want to do is control this movement. I'm going to control it by bringing in another piece of geometry, bring in a piston assembly that we're going to attach to these connection points that we've made. So I'm going to come over here and say, let's insert. Now there's nothing here in my current part studio that I'm working with. I got stuff for the chair. I've got this new stuff that I'm making. But I'm going to say, let's grab an assembly somewhere else. And I can search for it by name. I can just kind of search through my things here and just kind of visually look through the thumbnails. Here's a piston. So I want to use this. I'll bring it in and kind of place it right here. So it's just kind of sitting in space right now. I can pick on this piston here, and I could say, let's kind of rotate them around a little bit, and then maybe kind of rotate them this way. So at least I got kind of a straight shot. And actually with this guy, let's turn him around so we can see the words here, because that look a little bit nicer. So I'm going to go in and assemble in this piston. So again, I'm just going to come over here and say, let's put in a revolute joint. And you'll notice when I'm putting assemblies together, it's really, really easy for me. I just need to pick really one point on one part and one on the other. And the majority of the time, that's all you're going to have to do, which is really kind of nice. So, and you notice it has all these locations where I can put it, all these different locations around here. I can also hard code in kind of a location for this. So it puts it in, these two faces are touching each other. So I'm going to kind of offset it a little bit. We could say like, 4 millimeters or something like that. So he's centered. So now he is attached. And now we can kind of start working with the back part, which we see right here. And with this one, let's kind of turn them around a little bit. And the same type of thing. In this case, I'm not going to use a revolute joint, but I'm going to use a cylindrical joint. And what that allows it to do is it'll still align holes, but it'll also allow it to slide along the axis. So it kind of keeps alignment with the piston here. So simple thing, just come in. Again, just have to pick 2 locations. So I'll pick this center and this center. It puts that in. And so now we've got our piston in here. The holes are aligned, both sides. If we take our back portion, we can now move it. Now we've got a nice mechanism set up. So we've modified this single stamped part into a couple of components, and then we've added a third to it. So the next thing we do is we want to apply this to the chair. So I'll go back to the chair. Here's our chair. Now, because I'm doing old school CAD, which in Onshape I wouldn't do and I wouldn't have to do it, I'm going to get rid of this. So I'm using the barbaric practice of delete and reassemble. Right? You don't have to do that in Onshape, but I'm doing it here just because that's what CAD guys do, because they have to. I'm going to come pick on this part. I'm going to say the old part, and let's delete him. So he's gone. And now I can assemble in the part that I made, or the parts that I made. So I'm just going to say, let's insert. I'm going to, it's an assembly, and this is the guy. And because it was using the old part, the way it was oriented, at least comes in the right location, which is nice. So we have that here. So he's just placed there. He's not intelligently assembled. Let's kind of take this. I'm going to just kind of move that. So I could leave it here and it's in the right position, but I want to put it in here because we want to be able to swivel the chair and also lean back on it. So I'm going to pull this up a little bit. And I'm going to assemble him on here again with a revolute joint. So that's going to allow the chair to kind of, we'll say this guy with this guy right there. So now he's there and now he can rotate. Another thing that I'm going to do, let's move this guy out because he wasn't really assembled. And we're going to also, because he's going to rotate, right? When the chair rotates, this guy needs to go as well. So again, just another simple pin joint, the center of this with a little bit easier to see it here, to the center of that. You know, it's just 2 picks and we've got things aligned. So now if I take this and I rotate it, it's doing what I expect it to do. Let's go and assemble the bottom of the chair on here. So the chair could just use a regular fasten joint, right? So we don't want it to rotate or anything like that. Again, line up one hole with the other. The holes are, you know, we use the original hole so we know that everything lines up. And now we've got the bottom of our chair assembled. We have to do the same with the back. So we want to assemble him onto the new components. So same type of thing. We're just going to say, let's take the center of this, and line it up with the corresponding hole. And again, I only have to line it up with one hole. So now we have our chair assembly. We can rotate them. We can take them and roll them back. One of the things you'll notice, that I notice, is looking at this thing, is that there's a big gap between here. I remember I was just kind of extruding these things out and doing that, and I've lost enough stuff in the cushions of my couch to know that we want to kind of have this a little bit tighter here, so things aren't falling on the floor. So I'm going to go and fix this, but I'm going to fix it where I found the problem, which is right here in the assembly. So I'm going to pick on our component. I'm going to say, let's just go and edit this part. And so now it kind of highlights our parts that we've created and allows us to make, and you notice the tree over here was listing all the components before. Now it's listing all the features of those components. So I'm just going to come over here and say, one of the things that we did is we moved that face. So I changed that. I gave it like a distance of 55. Remember, I just made up a number, right? Something that eyeballed it looked good. But I'm going to say, let's move that smaller. Let's say it's only 40 millimeters. So that changes that. It pulls that back, which will pull back the hole, which is good. So now the part has been pulled back. Then it says, let's go back to the assembly. When we go back to the assembly, it reassembles, puts everything together. When I do that, you know, it's a lot tighter here. So what we've done is we've basically taken a single component, broken it into 2, turned it into a mechanism assembly, and then reassembled it in here. Now the thing with this is I did this old school CAD way. You know, it took me, what, 19, 20 minutes, something like that to do that. If I would have been using Onshape the way you should use Onshape, I would have first of all gone over here and shared this design with somebody and said, after I broke it into 2 pieces, I'd work on one of them, I'd have a buddy of mine work on the other. And we talked to everybody, and a lot of people say, well, we've got our processes where we usually just have one person doing the work. And the reason you do is because you can't have two people doing the work. No one can do real-time collaboration. So they say, well, we don't really collaborate. Well, it's because you cannot collaborate. None of the systems out there allow you to do that. So that would save us some time, two people building parts at the same time. Another thing that I would have done is I would have, instead of doing a save as, you notice there's no save. You can look in all the menus in Onshape. There's no save. Everything is preserved, everything I do, so I can go back to any point in time. But the thing is that I would have done a branch. So with this design, I would have said, let's just branch off and make this new version. And then when I had the new version, I could say, let's merge that in with the old one and replace it. So instead of me doing a delete and reassemble, I would just do merge this branch in and things would have updated. So again, that would save me even more time. So even though I did this simple example pretty quickly using old school CAD techniques, if you do it in Onshape, it would have taken a whole lot less time, and we would have used some cool tools that people typically don't have available to them. Branching, sharing things, real-time collaboration, all of that doesn't exist in the typical CAD systems that are out there. So all I'm trying to do is highlight here is that on its own, Onshape can stand toe-to-toe with any modeler that's out there. But there's a lot of capabilities. If you watch any of the other videos that we put out there, they highlight the things that Onshape can do that the others cannot.